Okay, so listen up. Today, guys, phone away. So today we start technically the toughest part of quadratics, which always begins with this word, factoring. Factoring is always the most elaborate part of quadratics, and this factoring thing is going to take us today. Today is Tuesday, probably the end of the week. Okay, so about 4 days of factoring. If you get it right in grade 11, you should have absolutely no problems in grade 12, because whoever's going to teach you grade 12, probably Mr. Fonseca, is literally going to actually use the same techniques I'm using here. Okay? Okay. What was the technique that we learned yesterday? Like, what's the technique when you multiply things through? When you have two brackets, and when you go from factor to standard, what's the name of the technique? X. No, simplifies when you clean it up. But when you actually multiply, what do you call that? X. Come on. Expanding. Today we do what? No. Today we do, which is the opposite of expanding. Today I'm going to give you something with no brackets, and I'm going to ask you to create what? Brackets. Okay. So the first thing we have to understand is that the entire lesson for today is this. How many people have heard of something called the greatest common factor? Raise your hand if you heard the greatest common factor. Yes, you heard of it, but probably not in not in a equation way, but when you were given a bunch of numbers and you're just being asked, hey, what's the greatest common factor? Okay, there's another name for it, the greatest common what? Divider, which I like more because it tells you exactly what it does. Basically, the whole job for today is to look at everything here and see what is the greatest common divider of everything here. Okay, first is first. What numbers do we have here? Not exponents. What numbers? 8 and 6. What kind of numbers are 8 and 6? Even. All even numbers divide what? Great. So we can say, this is the way I want you to always look at it. And just before that, let me just do just one small thing so I can give myself some lines to write on. Picture format, color, make it transparent. And I'm going to view my grid lines. There we go. Perfect. Okay. So the first thing I want you to write is this. Actually, let me see how I wrote it before, so I exactly do. Yes. Okay. So look at numbers. Go ahead. Write this down. Look at numbers. What are the only numbers we have? 8 and 6. 8 and 6. What numbers do they divide? Actually, they also divide another number. All numbers divide what? By 1. Perfect. So, okay, there are always multiple answers, but there is always one single what? Single like collection of choices. Do you see what I mean? Yes, there is always, usually, there is more than one number they divide, unless they only divide what? 1. But if they divide more than a number, more than 1 and something else, you have to list all the numbers for me. So they divide 1, 2, anything else? What does 6 divide? 3 and 6, but 8 does not accept that. What does 8 divide that the 6 does not accept? 4 and 8. So you know what? The common list only includes 1 and 2. Which one is the biggest number of these? Great. I want you to either highlight or circle 2. Okay. Now let's look at the variables. Is there a variable with the second thing? No, is there a variable next to the 6? Yeah, it's x to the 4. Is there a variable next to the 8? So can I say there's a common variable between the two? No. See, this has to have an x with something for the x's to be what? For the x's to be common. So we're going to say, look at the numbers, done. And then we're going to say what? No common variable. Go ahead. No common variable. Which means we're done. The greatest common divider is just what? It's just the, perfect. It's just the 2. Good. It's just so. Okay, we're going to start writing it in what? In a short form today. Greatest common divisor. GC, greatest common divisor. GCD. Or sometimes some people call it GCF because they call it the greatest common factor. I'm going to go with divisor today. So GCD is just what? Is just what? 2. That's it. It's just 2. Oh, GCD, greatest common divisor. Everyone, go up here. Greatest common factor. Again, I'm not gonna, whether you call it GCF or GCD, it's up to you. So I want you to write here GCF or GCD. But I'm going to usually call it D because I like the word divider more than factor because it tells you exactly what it does. Okay? Everything we're going to do for the first page is just like that. Okay, let's look at the second one. 2 and 4. 2 and 4. What do they both divide? They always divide what? You have to tell me what? No, you have to tell me what first. You have got to tell me 1. By the way, I know that all numbers divide 1, but I can tell you for a fact that many math teachers, if you do not list the 1 in the list, they will take half a mark off. So I'm just trying to make sure that you remember. So, yes, so look at the numbers. Sorry, look at numbers. Um, 2 and 4. They divide 1 and 2. Which one is the biggest? Doesn't matter. But here's the thing. Listing is always helpful. So that's why I like 1 and you go up. Okay. How about the variables or the symbols? By the way, variable symbols mean the same thing. What symbol is with the 2? Is there any symbol with the 4? No common variable or no common symbol. No. Oops, my bad. Come on. Go away. Yes. Not yet. Still working on it. I'll send a mass email once I do that. So everyone can go and check. No common. That's a bad M. There we go. Now it's a good M. No common variable. Which means, so our GCD is only what? Come on, it's whatever is highlighted in green. 2. By the way, that's how easy today's lesson is. That's all. Yes, as long as you only have what? 1 highlighted in green, that's the answer. Yeah. That's the second page. And the second page, I'm going to show you how to use this to create the brackets. Today, I'm taking steps. The first step is just to know what's the number that we need. No. The first page is only to find what number is important. The second page, we're going to create the brackets. Okay? All right. Next one. Okay, now things are getting interesting. Again, let's look at the numbers. What numbers do I have? Come on. 4 and 12. What do they all divide? 1. Oh, hold on. I need the full list. 1 and 2 and 4. What's the highest one on the list? 4. Okay, let's look at the variable. Can someone tell me what's the variable next to the 4? Caleb, what's up? Oh, you're right. Thank you. My bad, everyone. 4 and 12. Thanks. What's the variable next to the 4? N with what power? 9. So 9 copies of N. What is the, go ahead. Oh, no. Hold on. What do they sorry, by the way, it should be they divide. I am only talking about the numbers common to both of them. 6 and 3 are only common to what? 12. Can't. I need only the list of numbers common to both. That's why we call them common. How many powers of n do I have in the first one? How many powers of n do I have in the second one? Oh, you're giving me 0. It's not 0. If it doesn't show, it's a what? It's a 1. So I want you to put 1 on top. Every time you don't see a power on top of a variable, put what? Put 1. No. What if you keep forgetting? There you go. So everyone, I'm going to add it in red. 1. So apparently, how many n's are with the 4? How many copies of n is with the 4? 9. How many copies of n is with the 12? Can both of them offer me something? Yes. Only how much? Because you always go by the weakest link. Can this, okay, everyone, question. Can this one offer you 1 n? 2, 3, 4, 5, 6, 7, 8, 9. Can this one offer you 1 n? Can it offer you 2? So that means what? The most you can take of both at once is just how many? Everyone, from now on, you always take the what? The lowest power. Always take the lowest power because that's guaranteed to be offered by both. All right. So what should we write? Before we wrote what? No common variable. Now, yeah, go ahead. So what if this one is, for example, 7? Great. Then you still take the what? The lowest one, which is 7. Do you see what I mean? This one can offer you 9 copies. If this one was a 7, it could offer you how many copies? 7. So that means what? Out of both at once, the maximum you can take is what? 7, if it were a 7. Do you see what I mean? You always can take the lowest number of copies possible for what? For the lowest one. Always like that. That's why I like to say what? Take the lowest number offered. So what are we going to say? We're going to say what? What's a good way to say this? We can say we can only take how many powers? How many? What you can always take the lowest. That's it. Look at variables. Come on. Look at variables. We have n to the 9 and n to the 1. We can take n to the 1. So go ahead, highlight this one now. How many things did I highlight here? How many things did I highlight? 2. I highlighted a number and I highlighted a variable with a power. Great. My GCD are those 2 things multiplied together. So G, yeah, 4. So GCD is 4 n to the power of what? That's it. Go ahead. Go. By the way, this will make so much more sense when we flip the page and we create the brackets. We have not created brackets yet. I am just telling myself what can I take out. Yep. Okay, can someone tell me what's the situation for 3r plus 9? Look at the numbers. We have 3 and 9. What do they only divide together? 1 and 3. Okay, so everyone. So we see both together. There we go. Look at numbers. By the way, just so you know, everyone, listen up. You don't have to show me all this written every single time. By the end of this lesson, all you can write is just what? GCD is 4 n to the 1 or 2. You just need to show me the final answer. I am just showing you how to find the final answer. That's all. Never once For the rest of the course, you actually have to tell me, look at numbers. 412, they divide. No, no, no. I know that if you got that, look, I know if you got that, you must have definitely done all of this. So you don't have to show it every time. Look at numbers. Yep. What do they divide? 1 and 3, and that's it. You can't say 9 because only 9 divides itself. Too big for 3. They divide. They divide 1, comma 3. Highlight the biggest one always because it's the greatest. That's what we call it. No one ever talks about the lowest common divider. No one. We always talk about the greatest. Why take the lowest when you can always shoot for the highest? Okay. Are there any common variables between the two? What is the variable with the 3? Is there any variable with the 9? Done. No common variable. No common variable. Which means, so GCD is just what? Just whatever you highlight in green. 3. Whoops, my bad. Okay. How about the next one? What numbers do I have? What did you say? See, Aya did not just say 12 and 3. You said what? You said negative 12 and negative 3. Good. Okay. So look at numbers. What did you say? You said negative 12 and negative 3. Okay. They divide. They divide. Let me squeeze those so they don't go into the other space. There we go. Forget the minuses for a second. What the? Go ahead. Just let me just finish this one. If we forget the minuses, they're still important, but let's just forget about them for now. What does 12 and 3 divide? Common. 1 and, but do both of them also have a minus? Great. Today's lesson is common, which means if there is something common in everything, you also take it. So instead of just saying, 1 and 3, we're going to say negative 1 and, exactly, when both of them are negative, take the negative with it. So they divide negative 1 and negative 3. So go ahead, highlight this guy. What's the variable situation? Sebastian, what's the variable with the negative 12? What's the variable with the 3? Nothing. Done. No common variable. Sorry. No common variable. Which means so my GCD, bless you, is just how much? Whatever you have in green, which is negative 3. Very good. How about, what do you think of 5 and 4? Just what? Just 1. Bless you. Just 1. Everyone, 5 divides what? 1 and 5. 4 divides what? 1 and 2 and 4. But the only thing they share in common is 1. I know it's, you might say, didn't you just say all numbers divide 1? I did. Which means if that's the only one they divide, you still have to list it. Okay? So look at numbers. Look at numbers. Let me fix the M. Was it? Oh, 5 and 4. They divide only 1 together. Well, if it's only the only one on the list, you have to highlight it. What's the variable situation? Sebastian, what's the variable with the 5? With what power? Nice. What's the variable with the 4? R to the 4. So everyone, I want you to add a power of 1 on top of this. So what can you take out variable-wise? The biggest one or the lowest one? Always the lowest one. So what can you take? Only the what? R to the power of 1. That's it. So I'm just going to say it exactly the same way we wrote it here. What did we write here? Look at variables. R to the 1, R to the 4. We can take R to the 1. Nice. So look. Oops, my bad. Look at variables. R to the 1, comma, R to the 4. I think what did we say? Sorry, 1 second. We can take. Okay, I'm just trying to rephrase it the same way. We can take. I need more space. Give me 1 second. Take this one and move it. Perfect. We can take. Christian, which one? R to the lowest power. Thank you. Highlight. So can you tell me now what's my GCD? If I have two, sorry, this. Exactly. 1 R to R1. Yes. So let me. Give me 1 second. Now I really. Yes. All right. So GCD is 1 R1. 12 and 16. Anyone? What numbers do they divide? Other 1, 2. How about 3? Exactly. And the key word is common, right? Common means both have to be in agreement. So what is it? 1, 2, and? How about 6? 6 only works for the 12, not the 16. How about 8? Vice versa, works for 16. So you know what? Look at numbers. Look at numbers. 12, comma 16. They divide 1. Sorry, let me just write here. 1, 2, and 4. Doesn't go higher than this, so I'll highlight the 4. Okay, can someone tell me the variable situation? Kylan? Yes, what's up? Hello. All of them are open anytime. Yep. All right. Yeah, Rachel? Mr. Barbara. Okay, Kylan, what's the variable situation? What's the variable with the 12? To the? Sorry, yeah, you actually technically you're right. If I just say what's the variable with the 12, you should just say n. But I also mean with the power. How many powers do you have? 5. How many powers do you have with the n next to the 16? 3. Which one do we take? High or low? Nice. That's it. Okay, so look at variables. Ooh. Look at variables. n to the 5. Let me just squeeze a little bit above. Yeah, that's good. N to the 5, comma, n to the 3. What did we say? We can take n to the 3. We can take n to the 3. Highlight. So can someone tell me what's my sorry. So can someone tell me what's my GCD now? Other than Christian. He's been fielding almost every question. Come on, people. You just need to tell me what the two things. Yes, Maria? Maria, go ahead. Yeah. 4. What did you say? 16. Maria. Sorry, Noor. Sorry. Yeah, but I already highlighted that we can take it. So now I just want you to tell me the final answer. The final answer is just you put these two next to each other, like we did every time. Okay? All right. So GCD is, as Maria said, 4n to the 3. Done. Okay, everyone. I want to do just one more on this page because I really want to show you how we can create the brackets on the second page. Okay, I'm going to do this one. The one with how many things? So this is what we call a trinomial. Tri means what? Triangle, tricycle, and so on. So trinomial means something with 3 things. 1, 2, 3. All right. So everyone, let's look at this. Okay, same thing. Let's look at the numbers. Come on, go down. All right. 63, 49, 21. Obviously, they all divide what? 1. So that's done. Do you think 2 works? Do you think 3 works? Yeah, you're right. It works for this guy and this guy, but not for what? By the way, do you think any even number is going to be a common factor? No, exactly. All of those numbers are what? Odd. Sorry, if all of them are odd, they could never divide even numbers. Okay, everyone, look at the smallest number of all. What's the smallest number of these 3? Okay, let's judge by that. What does 21 divide? 1, 3, 7. Do you think this divides 7? Perfect. 7 is the biggest one on the list. Great. So look at numbers. Sorry, what? 63, 49. By the way, you might say, hold on, why aren't you saying negative 49? Why do you think I did not bother saying negative 49 or negative 21? Only if there's a negative here, I'm going to put what? Only if there's a negative with all of them, I'm going to put a negative with each one. But you know what? If there's one that's different, just look at the numbers. So 63, 49, and 21, they divide. They all divide 1. They don't divide 2 all. They don't divide 3 all. They don't. So they only divide 1 and 7. By the way, do they all divide 21? No. 21 divides itself. 63 divides 21. 49 doesn't. So yep, the only 2 numbers on the list are the 1 and 7. Great. We got one thing highlighted. Okay, everyone, let's look at the variable situation. Let's go with Sebastian. Sebastian, how many copies of M do you have with the 63? 6 copies. How many copies of the M do you have with the 49? How many copies do we have with the 21? Nice. So what's our lowest one? 1. Great. So I'm going to put a 1 here to remind myself that it's not a 0. And then you can say, look at the variables. Look at variables. We have 3 this time. We have m to the 6, comma. We have m to the 5, comma. We have m to the 1. So we're going to say we can take, might have to squeeze a little bit. We can take, yeah, we're definitely going to have to squeeze. Hold on. There we go. We can take the smallest one, or sorry, the lowest one, I should say, m to the 1. So what's my GCD, everyone? Yep. 7 times m to the 1. Yep. So GCD is 7 m to the 1. And that's all we need to know about how to fish for those highlighted numbers. Yes, Caleb? Hopefully by lunch. Sorry, not by lunch. I mean by the end of the school day. Okay. Okay. Have we created any brackets yet? Not yet. But we now know how to take the common things out, or what common things are we potentially going to take out. Okay, everyone? So let's flip the page. Go ahead. Flip the page. Okay. I'm going to start, everyone. I'm going to start with that one. Everyone, I'm going to start. Oh, yeah, let me show the lines. The red color. Okay, now we're ready. Okay. Are we still going to start the same way? Yes. 81, 36, 18. Come on. What numbers do they divide? By the way, everyone, because now we're going to create brackets, I'm going to skip all the writing I did. I'm just going to tell myself the GCD is blah, blah, blah. Do you see what I mean? I'm skipping steps now because we've already built up to them. Colin, what do you want to say? They all divide 1. They also divide what? Is that the biggest they could go? Yes, you're right. They all, by the way, they all divide 1. They all also divide what? They all, I think so. Yes. 81 divides 3. 36 divides 3. 18 divides 3. They don't divide 4. They don't divide 5 or 6 or 7 or 8. But they all divide what? 9. So everyone, I want you just to write this now. They divide 1, 3, 9. So go ahead, highlight the 9. Yes. Because again, this was one stage. Now we're applying it. Do you see what I mean? I am still doing, so this question includes the first question. So now we are immediately saying, I'm looking at the numbers, but I'm not writing it down. Okay? Again, you can definitely start that way. 100%. Absolutely. It's just going to take you more time to write. Let's look at the variables. What is the variable with the 81? R to the power of 2. What's the variable with the 36? R to the power of 1. Exactly. There is none, which means there's 1. Is there any variable with the 18? No, which means what? Do we have any common variables? No, we don't. So I want you to write no common variables. You see, we're skipping so much. We're skipping all of these descriptive steps. We're jumping to that. We're jumping to that. And we're jumping to technically that if there were. So no common variables. No common variable. So the G, yes. So GCD is just 9. Okay, everyone, right up to 9, and then I want everyone to put pencils down and just focus on how I'm going to create the bracket. Because I just want you to see how I'm going to do it with no writing whatsoever. Okay, how do you create the bracket? First step, what's our GCD? Write it first. All right, 9. Open a bracket. Okay, everyone, eyes on the screen. What's my first number in the original expression? 81. What's 81 divided by 9? Nice. Do you think the r squared is going to change or stay the same? Hold on. Is there anything next to this 9 here? No, no. Right here. Right here. No, there isn't. Because there is what? If there are no common variables, all of these variables are going to stay the same. Okay, so it's going to be r squared minus, keep going. What's 36 divided by 9? 4. With what power? Just r to the 1. Minus, what's 18 divided by 9? Do you think we're done? Yes, we are. When you are done, what do you do to the bracket? You close. How do you check that your answer is correct? Expand, yeah, multiply it back. What's 9 times 9? What's 9 times 4? What's 9 times 2? That's why whenever you have a factoring question, technically you never need to ask a teacher, can you check my work? You don't need me to check your work. You can check what? You can check your own work by just what? Multiplying and just making sure you get the original numbers back. What if one of the numbers is different? What does that mean? No. That means you maybe made a mistake when you divided maybe the 81 by 9 or the 36 by 9 or the 18 by 9. That is how you what create the bracket. Okay? Everyone, let's do this one. Come on. What's the number situation? I've got 18, I've got 24, I've got 21. They all divide. They all divide 1. Do they all divide 3? How many? 2? No. Those two do. Everyone, look. Yes, 21 does not divide 2. Do they divide 3, all of them? By the way, factoring is doing a lot of multiplication table in your head in reverse, which is why sometimes some people struggle with it because you don't remember your multiplication. So 3 works. Hold on. Before you tell me the answers, can you think of any bigger number than 3 that they all divide? We said that 1 works. We said that 3 works. By the way, what's the smallest number in all of these? No. What's the smallest number in all of these? No. In these. No. In these. 18. In these. Always judge by the smallest one. What does 18 divide? Works with all of them. Does 18 divide 2? But it doesn't work with this guy. Skip it. Does it divide 3? And it works with these two. Does it divide? It doesn't divide 4. It doesn't divide 5. It does divide 6. But does 6 work with this one? 7. No. 8, 9. So indeed, the biggest number they all divide is what? Is 3. So we're going to say what first? No. Remember, that was the first page. Now I'm just going to start by saying this. Oh, my bad. One, comma, 3. What's the biggest of those? 3. What's the variable situation? N to the 3, N to the 1, and what then? Nothing. Sorry, no common variable. So what's my GCD only? 3, the only highlighted thing. Okay, let's create a bracket. What's the first thing I write? The 3. Whatever is my GCD, I write it first. Okay, so 3. Open your bracket. Now what do? How do you know what survives inside of the bracket? What do you do with each one of those numbers with the 3? Do you subtract or do you divide? By the way, you have no idea how many people think subtract. For some reason, they say, oh, just take 3 out of 18. It's not take, it's divide. Okay? So what's 18 divided by 3? Come on. 6. Is the n to the power of 3 going to change or stay the same? Stay the same. As long as there is no common variable, the variables are not touched. So 6n to the 3. Keep going. Minus. What's 24 divided by 3? 8. With what variable? Whatever it is, exactly. N. Oh, yes, so my bad. I forgot to indicate it's a power of 1. Not that you're going to lose marks if you don't. N to the power of 1. Minus. What's 21 divided by 3? 7. By itself, because it initially did not have any variable with it. How do you check your answer? 3 times 6 is 18. 3 times 8 is 24. 3 times 7 is 21. Please always multiply back to check. You never know when you make a mistake when you divide. Yes, we all do. Trust me, even I do that sometimes. Uh-huh. Exactly. Instead of dividing, we're multiplying. That's why I'm saying what factoring and expanding are what to each other? Are same or opposite? No, factoring and expanding. Yesterday we multiplied, today we divide. Today we divided to get those numbers. I'm just multiplying to check. You only multiply to check. Okay, let's do one with variables. Should we do this one? I mean, it's got numbers, but does it have a common variable? No, it doesn't. That one tells me the same thing here. So I'm going to skip this one. So let's do, so I'm just going to erase this. Oh, okay. Everyone, there we go. That. Okay, let's look at the numbers. 72, 72, and 80. Okay, let me show you the easy way. What's the smallest number of all of these? Come on, everyone. Phones away. Phones away. I'm only asking you for 15 minutes. That's all. Even less. What's the smallest number? 72. What does 72 divide? Okay. It's a big list. What's the first one? 1. What does 72 also divide? All even numbers divide 2. Do you think 72 divides 3? By the way, I know that some people are raising their hands because they already have the answer for the GCD. That's. Oh, go ahead. That's fine. But I want to build it up to it. 1. What also divides 72? 2. What also divides? 3. It divides 4. Do you think 72 divides 5? Does anyone know how you know a number divides 5? Only 2 kinds of numbers divide 5. Exactly. Either ending in what? Or 0. Sorry, 72 does not end in 5 or 0. So it doesn't do. Exactly. But I'm talking about the 72. Do you think 72 divides 6? Yeah. By the way, if you're interested in knowing if a number divides a number or not, just divide it and see if you get what? A whole number. 6 works. 12 works. 18 works. The biggest number that works for 72 and the what? And the what? And the 80? Nope. 80 does not divide 12. 80 does not divide 6. Nope. The biggest number is 4. I know it's kind of a trial and error. It's not really. You just need to list all of them and then try them with all of the numbers. So the biggest number is what? The biggest number is how much? Come on, 4. Okay. Actually, no, it's not 4. It's 8. By the way, I can show you a way where you can take it in small steps and still get the final answer at the end. Let's say you said 4. Everyone, let's say you said 4. Caleb, what's up? Oh, but remember, it's posted very soon. Everyone, let's say you divided by 4. Can someone tell me what's 72 divided by 4? 18. What's 7 divided by 4? 18. What's 8 divided by 4? 20. Hold on. Can you still divide those numbers even more? Come on. Can you divide those numbers even more? Yeah. By what? Actually, 20. No, common. What common divides also these? 2. So you divided by 4, and then you divided by 2, right? You divided by 4, and then you divided by 2. What's 4 times 2? 4 times 2? 8. That's how you know. Take it in small steps. That's fine. You will still get to the right answer. So we're going to write this. Now, oops, sorry. We're going to write, they divide. Oops. They divide 1, 2, 4, 8. That's my highest one. Can someone look at the variables and tell me what's going on here? What's the variable with the first 72? It's 5. What's the variable with this one? What's the variable with this one? What's the lowest one? 2. Perfect. So we can take x to the 2. Let me write a good x. So what's my GCD? 8x squared, or 8 times x squared. So GCD is, in black, 8x. So how do I create my bracket? What do I write first? I have to write the whole thing. You write whatever you took, you write the whole thing. So 8x squared. Okay. What's 72 divided by 8? Come on, people. What's 72 divided by 8? Anyone? You can just divide it on your calculator or cell phone. What's 72 divided by 8? Nope. Nope. Come on. You have a cell phone in your hand. It is 9. Okay. No, it is 9. How many powers do I have here? It's 9. Trust me, it's 9. It's okay. How many powers do we have here? Come on. How many did I put outside? So how many remain? This is what you do with variables. You just whatever one you 5 here, you took 2 outside. How many remain inside? Remember, we're gonna multiply and check. Aiden, what's up? Sorry, you need what? Yeah. Okay, next. Again, what's this 72 divided by 8? Another what? Come on, another 9. No, okay. How many powers do I have here? How many did I keep outside? So how many should remain inside? You got it. No. 1. Whatever you took outside, you just see how much is left for inside. That's how variables go. Minus. Who knows what's 80 divided by 8? 10. Perfect, 10. Well, I don't know. You tell me. How many powers do we have here? How many did I keep outside? So how much should be left inside? 0 or nothing, or say hello to your other side of the bracket. Done. How can you check? Multiply. Everyone, what's 8 times 9? What's x squared times x cubed? Ms. DeVilla's poster. There we go. What do you do when you multiply two identical things with powers on top? What happens to these two? You add them up. So if you multiplied x squared times x cubed, what do you do to the 2 and the 3? You what? What's 2 plus 3? Perfect. Keep going. What's 8 times 9? What's 2 plus 1? What's 8 times 10? X squared and nothing is just what? Perfect. Do you remember the other proof that two things are the same? What website do we always use? Say it. Desmos. I'm going to sketch this one, and I'm going to sketch this one. I'm going to prove to you they're going to be what? The exact same thing. Check this out, everyone. What's up? Just let me show this one. Okay, Ragat, tell me what's the first. What is it? 72. Let me just move this one here. All right. Come on. Okay. I'll just write it down. 72. 72. X with what power? Well, the original one. 5. Yep. Minus 72 x to the power of x to the 3. Sure. Minus 80 x to the power of 2. By the way, just so you know, everyone, is this a quadratic or no? It's not. Today we're not factoring quadratics. I'm just common factoring in general. I'm just taking stuff out. Okay. Let me actually play with the margins a little bit. I'm gonna go from minus 10, maybe 10. Now it's nice. Actually, I can even make it better. I can go from maybe minus 5 to 5. Yes. Now it's much more visible. Okay, Ragad, tell me the factored expression. Like the whole thing in black from beginning to end. 8. Everyone, watch how I'm building it. Just eyes on the screen. X to the power of 2. And then you open a what? You have to open a bracket. That's our job today. Yep. Oops, sorry, here. 9. X to the power of what? 3. Keep going. Minus 9. X to the power of 1. Sorry, 1. Minus what? Everyone ready? The blue curve will perfectly match with the red one. Perfect. Exactly the same thing. What does that tell you? Are those two things the same? They look different, but in math now we know things might look different, but not be different. Like when you simplify fractions, 4 over 8 is the same as 1 over 2. The numbers look different, but they are the same. Yes, Christian? Exactly. For every point, they match up. Okay. Let's do one more. Yes, go ahead. Okay, everyone, I want to do this one because it has how many kinds of variables? That one. 2 A's and that's fine. Okay, everyone, let's look at the numbers. 24, 36, 60. What do you think they all divide together? Of course, they divide 1. Of course, they divide 2. Of course, they divide 3. Of course, they divide 4. Do they divide 5, all of them? No. Exactly. 24 and 36 cannot accept a 5. Do they all accept 6? They do. Do they all accept 12? Anyone? Yes. 12 divides all of them. Yes. 12 is the biggest number. Great. So let's write that down. They divide. They divide. What did we say? 1, 2, 3, 4, 6, 8. By the way, no, not 8. Sorry. There's. I mean, what did we say? 12. Yeah. The biggest number is 12. All right? Tell me the variable situation. Come on, everyone. 1 second. Let me just finish this. How many copies of A do you have here? Come on. No. How many copies of A do you have here? How many copies of A? What's the power of A? 2. What's the power of A here? What's the power of A here? Interesting. So the A is common. All right, that's fine. So I'm going to put a 1 here and a 1 here. Okay, tell me the B situation. How many powers of B do you have in the first one? 2. How many powers of B do you have in the second one? How many powers of B do you have in the third one? Nothing. So which one is common, the A's or the B's? Just by looking, which one is common, the A's or the B's in all of them? A. So I'm going to say we can take A to the power of what? The smallest one, which is 1. Okay, let's highlight. So can someone tell me what's my GCD? What's my GCD? Oh, I just didn't hear it. Who said? 12. Perfect. 12 times, or just 12 A to the 1. 12 A to the 1. Okay. So how do I write my what? How do I write my bracket? What do I write first? Whatever you said is your GCD has got to be written first, all of it. So everyone, 12 A1. Open a bracket. What do you do now? Anyone? What do you do with the numbers? Do you multiply or divide? Now. No. You divide now. You multiply just to what? Just to see if just to check your answer if it's correct or not. Okay, let's divide. What's 24 divided by 12? Anyone? 2. But there's a what before it? Good. So -2. How many powers of A do you have here? How many did you steal outside? So how many should remain inside? You got it. Did you even touch the B's? Everyone, was the B's a part of the common factor? Which means what? Should they change or stay exactly the same? Stay exactly the same, which means B squared. Okay, keep going. Plus. Does anyone know what's 36 divided by 12? 3. How many powers of A do you have here? How many did you take outside? So nothing of the A's should remain inside. How about the B's? Do they change or stay? The B's have not been touched. Keep going. One last thing. Anyone for 60 divided by 12? Anyone knows it? I know it. 60 divided by 12. 5. How many powers of A do you have here? How many powers of A did you steal outside? So no A's inside in here. Also, is there a B here? What do I do now? Yep. How can you check? Yeah. What do? You multiply. Okay, quick. 12 times 2. Come on. 12 times 2. 24 with a minus. A to the 1 times A to the 1. What's 1 plus 1? And B squared is just the same. Keep going. 12 times 3. A to the 1. Nothing. B to the 1. 12 times 5. A to the 1.